This time, we will learn how to illustrate equal and equivalent sets. So actually, this lesson is all about how we can relate one set to another. So we have here three sets written in roster notation. So we have set A containing the elements mint, chocolate, lemon, and for set B, mint, strawberry, lemon, and set C containing the elements lemon, chocolate, and mint. So if you notice, all of these are sets of candies. But perhaps we're trying to make it more specific. So let's say among the list of set of candies, A would be the favorite set of candies of Leslie. Let's say B is for Jason, and then C is for Azul. So the question now is, which sets are equal? Yes, that's correct. It's A and C. So I will explain it later. But which sets are equivalent but not equal? Okay, that's correct. Set A and set B. So how do we differentiate the two if we say equal sets and equivalent sets? So looking at our examples, sets A and C are equal sets. Looking at the elements, A and C has lemon, A and C has chocolate, and A has mint. That means they are equal because they have exactly the same elements. But for equivalent sets, but take note, we're referring here but not equal. Equivalent sets, they might differ in a certain element, chocolate and strawberry, but when you try to look at the cardinality of A, or we can read that one as the number of elements in A, that's a 3, but the number of elements in B is also 3. And that makes them equivalent because they have the same cardinality. Therefore, our example a while ago, A and C, are also equivalent. They are equal at the same time, they are equivalent. So when you say equivalent sets but not equal, we're just referring to the cardinality of each sets. So this is now the formal definition to identify both, but I hope you were able to understand my explanation. So let's have some practice example. Let's state whether the sets are equal or equivalent. So we have here number 1, set K and set L. And number 2, set M and N. And number 3 is sets O and P. So I want you to pause this video and answer it first on your own. Okay, let's now try to look at the answer. So what will be our answer for this one? So take note, when we say equal sets, they have exactly the same elements. But for equivalent sets, that means that we're just referring to the cardinality or the number of elements and they're just the same. Okay, number 1, K and L, they have 5 and they have 6. That means that they have exactly the same number of elements at the same time, exact elements. They're equal sets. Number 2, sets M and N, they have green, blue, and red. That means they're also equal sets. Number 3, This is 2 and 4, 3 and 8. They don't have the same elements, so they're not equal sets anymore. But the cardinality of our O and the cardinality of our P is what? 2. Therefore, they are equivalent sets. In our answers in number 1 and 2, we can also say that they're equal sets and at the same time equivalent. But then again, it's okay not to say equivalent anymore because when you say they're equal, they're automatically equivalent. So that's why there's no need.